Aluminum smelting. Aluminum is a post-transition metal with 13 protons and 10 electrons when it is stable. It is the second most used metal in industry because of its cheapness, malleability, anti-corrosiveness, and recyclability. According to Elemental, it is the most common metal in the world, making up over 8% of the Earth's crust, but it's not naturally found by itself. In order to use the aluminum, we need to separate it from other compounds using smelting. According to how stuff works, smelting aluminum today is done through a process called electrolysis, where decomposition in a compound happens using electricity. The most basic setup for electrolysis happens when you put two electrodes, which are conductors of electricity, into a substance. We had studied in the last year's electricity unit that one is the positive terminal, the anode, and the other is the negative terminal, the cathode. Since positives attract, negative ions attract towards the positive terminal, the anode, and vice versa. Because of this, the positively charged aluminum attracts to the negatively charged cathodes, and carbon to the anodes. Before 1886, aluminum was really hard to extract, but electrolysis made it much cheaper. Aluminum oxide, which is Al2O3, a white powder in normal room temperature, reacts with the carbon anodes to make carbon dioxide and pure aluminum, which sinks to the bottom of the container. Before this can happen, aluminum needs to be liquid. Usually the compound is melted in cryolites, which is Na3AlF6 at 1000 degrees Celsius, so that the smelting can happen at half the temperature. Thanks to this, aluminum can be created at a relatively cheap price. This is an easily malleable, anti-corrosive, and resistant metal, as said earlier, used everywhere today, from Coke cans to iPhones to airplanes. 1 million people in China work in this industry, and in the US this number is at 672,000. Production was at 58 million tons last year, and ever since the discovery of the smelting process, it has only been increasing. Aluminum is essential for construction and transportation, which account for half the aluminum production globally. In automobiles, for example, aluminum makes cars safer, since they can be packed thickly as they weigh less. As opposed to steel, according to the Aluminum Association, which would cost 50% more and absorb only half as much of the shock during a crash. On the other hand, aluminum is a danger to the environment, says Recycle Nation. In smelting aluminum oxide, carbon dioxide is produced. In order to extract the aluminum, huge quantities of electricity are required to heat the metal and then reduce it. Bauxite, which is a compound used to make aluminum oxide, is taken after completely removing vegetation from mining areas. According to World Aluminum, over 44,260 kilowatt hours of energy was spent making aluminum in 2014. This likely came from mostly non-renewable sources, since renewable sources only account for a bit more than 15% of total energy production, including nuclear energy. Because of the carbon dioxide released in the process, if the average ton of aluminum makes 13.7 tons of CO2, then last year we could predict that 794.6 million tons of CO2 were made in producing aluminum. This is theoretically equal to the mass of more than 9,000 cruise ships. However, aluminum is also 100% recyclable and will never lose any of its traits when it's recycled, as opposed to steel's 88% recyclability. Recycling aluminum takes just 5% of the electricity and releases 5% of the CO2 originally released when the aluminum was first made. It is also a very economic recycling process for municipalities. Right now, the main type of reaction to smelt aluminum is thus: 2 aluminum oxide plus 3 carbon, which are the cathodes, makes 4 pure aluminum plus 3 carbon dioxide. In order to make this reaction more efficient, all that has to be done is to increase the voltage of the battery. This is because Ohm's law, where voltage equals current times resistance, and thus current equals voltage divided by resistance, would mean that if we increased voltage, we would get more currents, or flow of electrons, as we studied last year. As a result of this, the cathodes will be able to attract more aluminum in less time, or the same amount of aluminum in less time, making the reaction more efficient. We could also increase the temperature of aluminum oxide so that it is able to split apart in less time than usual. This is due to collision theory. As the temperature increases, the molecules will move around more. Then, it is more likely that they will collide in the correct orientation to split apart and attract the cathodes and anodes. The carbon cathodes could also increase in surface area, become longer and thinner, in order to increase the area in which the aluminum has to contact. In order not to produce carbon dioxide, a different kind of anode, which attracts the negatively charged oxygen, could be used, which is not carbon, so that it does not produce carbon dioxide. Theoretically, if silicon anodes could be used, since silicon has the same charge as carbon, silicon dioxide would be produced. According to Lentech and Nanopartikel, silicon dioxide has no negative effects recorded on the environment thus far, after studies were carried out. Unfortunately, none of these solutions are, theoretically, financially viable. First of all, massive amounts of energy are already required in order to raise the temperature of aluminum oxide to 1000 degrees. If we increased it to, say, 1500 degrees, we would get the following numbers. Since the specific heat of aluminum oxide is around 955 joules per kilogram, we'd first have to multiply that by 200 tons, since 200 tons of aluminum oxide makes 1 ton of aluminum. We would get the following number and then multiply that by the temperature we need, 1500 degrees, which would give us a required amount of 286.5 million joules. This number would be around 80 kilowatt hours, and using the average Turkish electricity price, which is taken from the Doğan news agency, we could say that 21.6 TL would be produced per ton of aluminum made. This might not sound much, until we realize that the average aluminum plant can produce 1 million tons of aluminum each year. Increasing the voltage of the battery could work, although that would require more energy, and thus more money. Furthermore, if aluminum would be produced more quickly, the extraction from the cathode vat would also have to be enhanced to meet these rates. And since aluminum demand in the world needs to increase before more can be produced, it would also make not sense financially to produce more. As for the silicon cathodes, these only exist in electronics chips since they are not cheap. A 1-ton carbon anode, which is basically a brick, would cost up to $600 in average prices. But if this was made out of silicon, it would, using US silicon prices, theoretically cost $2,540 instead.